Hey, it's Nicole here from Shared Everything, and I have Jeff Denworth, Vast co-founder, with me. Hey.
Hi, Nicole.
Hi, we are here at GTC DC, sitting down, taking a little bit of a break. How are you?
In a podcast studio.
I know.
Over top of a yoga studio.
This is pretty cool. You're gonna do yoga after this, right?
Super relaxed.
Yeah.
Yeah.
So we had time to sit down, and I thought it would be a good chance for us to talk about a dot release. I know everyone gets very excited about a dot release, but I think what's missing here is just how big of a change this represents. This is not just a minor addition to what VAST does. This is a rethink of what's possible.
Mm-hmm.
And I'd love for you to explain the various parts of the platform and what it changes to have these new layers.
Sure. So 5.4, which just came out 3 days ago, I want to say, is definitely the largest software release that we've made to date. I just tried to scroll through the number of features that are inside of it. It's maybe something like 50 or 60 new features. Right?
I got the documentation on it, and I was like, well, how do I do this in my head all at once?
Right.
Yeah.
But I think we screwed up a little bit in that, you know, if we were to kind of take a step back and look at it objectively, it would be called at least 6 or maybe 1. And why do I say 1? Well, you know, when we started the company, we kind of had this idea that we could build a computer and software that was just massively scalable. And the idea was, okay, well, you know, we need to be able to program to this thing. And then we didn't do anything on that domain for many, many years as we just started building in layers of capability. And so we started at the storage layer. Then we added database services about 3 years ago. And the story that I always like to use is, if you take like a standard keynote that Jensen gives, he always invariably, he almost always talks about, you know, when AlexNet was invented and you could finally understand a cat from a cat video by sending it through a neural network. And we look at that and we say, okay, well, you have 3 things. You have the raw data product that comes in this case from the natural world. Somebody takes a video with their iPhone or something like that. And then you have the context that before vector databases became popular and before RAG was a thing, largely just came from annotation that you could put in a database. And then you had the thing that refined a data product from being raw into something that could be understood and contextualized and queried upon for business purposes. And so here you have a storage system, you have a database, and you have a computer, right? And so 5.4 is a really, really big release for us because it is the first release that supports a full distributed runtime, a serverless environment that supports at scale eventing infrastructure. And so now when a piece of data hits the system, you can just add a few functions and the machine will get to work on contextualizing and storing all that data in a place where the additional metadata in a place where you can go query upon it. So metadata is an interesting concept or topic as well because all of these new AI embedding models, they take they can understand how to read through a piece of data, and they create an expression of that data that can be used by AI tools in the form of a vector. And so the second big feature that comes with 5.4 among the 50 or 60 that we've created is support for vectors as a data type in the vector database. And so that then becomes the kind of the key element for structuring unstructured data that can be used by Gen AI tools through standard interfaces like LangChain or LangGraph, or you can even just do like a SQL query on top of vectors.
Maybe just for those who don't know this because they're not using Gen AI at this level, but what does the addition of having this vector capability mean on the ground? So you used at the beginning the cat video example.
Yeah.
And you walked us through, okay, well, here's what you have now. So where does the vector side of that fit, and why is this a game changer?
So if you've ever used ChatGPT and you ask a question and it says searching the web, I don't know the specifics about how they've implemented, but most times when you see something like that in any generative AI tool, they don't mean they're actually searching the web. They're going through a set of pre-indexed data that ultimately is being done with what's called a nearest neighbor search. And so Similarity is the search function that is used for vector search. You know it well because every time you put in like a search in Google, it gives you a ranked set of results. And so basically similarity just allows you to do distance calculation between what you put in and what else is already pre-existing in the system. So now if you want to build essentially a search engine or to do retrieval augmented generative AI, then vectors become the thing that allow you to not have fully omniscient models. And you can just have a Gen AI tool go off to some supplemental data source, say, okay, well, I want to see every document that, kind of has these properties in it. Let's say I'm looking for, some sort of bad clause that was implemented in some of my contracts. Well, I can very easily search through that space to find those. And so for a lot of our customers, they're now using these RAG pipelines to basically feed agents with an information type that is contextualized in a way that an agent or a Gen AI tool needs to be able to interact with it.
What are some other business use cases of this? Like, where do you see this being adopted and most valuable?
So there's what's most valuable for the world, and then there's most valuable for Vast. Okay. I think about the latter a little bit more than I do the former, which I probably should do the other way. Okay, so we look at it and we say, okay, well, we need to sell some stuff this year. So let's go where the data sources are large, and let's go where the GPU density is pretty high because people will need scale and scalable systems. So we were just selected, and I'm sure we'll be able to talk about this a little bit more in the future, but we were just selected for a large government smart city project where customers taking a bunch of sensor data, a fair bit of video surveillance data, and running it through a RAG engine so that it can be accessed by an agent that is essentially the equivalence of having a security guard look at a bunch of monitors to figure out what's happening. So there's been this this is the thing that smacked me in the face and made me understand, okay, reasoning has really changed the fundamental understanding and definition of what's happening in AI, in that, previously if you had, Jensen uses the term perception AI. You could run a video through some sort of neural network and you could identify a cat or a ball or a person or whatever. But you couldn't necessarily understand the context of what was happening in between those, right? And so now that we can reason on these things using GPUs, it turns out that you can just get so much better situational understanding of what's happening within any sort of thing. So imagine a bunch of video data is coming in, it's being reasoned upon by an AI agent. And then there are other agents that decide what to do in terms of actions. Okay,
like alert the authorities.
Go call the fire department, or go write a report about this, and everything can be done completely systematically. So, wow. So that's a pretty amazing one. We have a bunch of projects going on like that around the world. Then on the media side, we made some announcements a few months ago with NHL, and they've been a great customer of ours. And they are very indicative of sports broadcasters, sports leagues, and news broadcasters that have just accumulated a ton of content that they didn't create themselves. Meaning, like, if I'm just, if you're television production, you get to write the script and do that whatever you want to. But in the other cases where you're just capturing live feeds, then there needs to be something that first understands that. And so here now you have reasoning models that can understand what's going on in video, VLMs, and then two, you can give these agents tasks to say, okay, create me a summarization of X, Y, Z, go create this user a personalized fan experience or things like that. And so there's a lot of work that we're doing in the media space. You can take that same concept, drive it over to Washington, D.C., and assume that we're doing a fair bit of that work in the homeland security space.
Sure.
Stuff I can't talk about.
Beyond smart city type stuff, too.
Smart countries, smart worlds.
Interesting.
And then the final one, and the one that I think is maybe my favorite, is on the vector database side, we're finding that a lot of customers have been looking for two things in particular as it relates to vectors that have never before been possible. The first is the ability to write into a vector space at very, very high levels of performance, because once I've made the conclusion that I want to kind of build a business on these unstructured data streams that I go and contextualize, well, sometimes that can be pretty significant, right? You have, in certain cases, like, millions of events happening in a second. And so because most of the vector databases in the world were built on kind of those legacy architectures that we like to talk about, shared nothing, which is the opposite of this podcast, there's just a whole wide open space for people that want real-time vector inserts so that they can do real-time queries. And the other one is just scale, right? And people are paying king's ransoms for vector database infrastructure, these machines that have just a ton of memory in there to put your indices in, and a variety of other kind of unnatural scaling things that have to happen just to even build moderately large vector stores. And we're building a system that can scale to trillions of vectors that you can search through in constant time without having to pay a king's ransom. And the cool thing is it's just a subcomponent of like a larger distributed system architecture that we're building. So internet companies actually become really interesting. And there's kind of two types I see here. The first is you have AI labs, which are largely all becoming internet companies in and of themselves.
Yeah.
Right? OpenAI is just releasing their browser now. Did you download it?
Not yet.
I didn't either, but I wanted to. It's just a busy week.
Yeah.
And so you have AI labs that are becoming internet companies, and then you have internet companies that are becoming AI labs.
Right.
And in both cases, I think anybody that's dealing with like social media or social content, anything like that, they're just going to be dealing with so much data that they want to enrich. And our solution is appearing to be really, really special in the space.
Yeah.
So we had one of the largest technology companies in the world the other day tell me they've tried out 20 different vector databases, and they haven't been able to find anything that's very scalable or anywhere near as performant as they need it to be.
Do they talk about the complete package, as it were? So it's not just the
not always.
It's that you have the speed, and you have there's a hardware story to be told here too. There's a systems story also that's really important to VAST beyond all of the genius software that's going on.
I agree. And it's funny that you say that. I was watching the keynote, the GTC keynote today, and I was thinking to myself, if I go back to like the earliest days of Apple's, like, they would hold like little town halls around Cupertino. They would show all the new processors that they built and things like that. It feels like you're almost back to that era where hardware really matters, right? And Jensen's got this like giant GPU he holds up on stage, and he's got machines that are popping up here and there. And I'm a hardware guy, so I appreciate that. But I think it's not hardware or software. It's how the two come together.
Systems.
Yep. And
systems thinking.
And here, like, our objective is always to drive the maximum amount of efficiency that we can. And I guess that means we're trying to drive down token cost, but trying not to sound too AI slimy.
It's not AI slimy. I actually think it's hard for me to not come across salesy sometimes when I'm talking about what we do, because that distributed shared everything architecture that we have is really important right now. And as I look to all the things that Jensen was talking about building, this future of millions of sensing machines in real time, smart cities, etc., I think this is the only kind of substrate that you can build from it. If it's not vast, it kind of has to look like this. Why is that?
I think it's a notion of parallelism. I actually read a book called Thinking Machines. Did you read this?
I have.
Yeah, it told you a lot of stuff that you already knew, but there were a few things that I don't think I fully appreciated. Like when the discussion around how there hadn't actually been a successful parallel computer up until CUDA was coupled with the GPU. I don't think I fully appreciated that. You could have a CPU with a set of cores in it, but those cores were kind of managed in a monolithic fashion versus. So anyway, I think a lot about parallelism, and I've been in the parallel file system space for far too long. And the interesting thing about this architecture that we built, this disaggregated shared everything architecture, is my belief is it's the first embarrassingly parallel system, distributed system, that's ever been built. We built this cluster architecture where no two machines have to talk to each other at all to do anything. And so that gets really interesting as it relates to just being able to handle the scale needs of some of the largest customers that we work with in the world. Like, we made announcements in the past with organizations like XAI, and they're making massive investments. But it pays even more interesting dividends when we stop dabbling in the storage space and we start working on some new data types that have been very, very plagued by intercommunication between different machines as you build out large clusters. So vector databases is a great example of that. We met another AI lab the other day. They had to build their own event streaming infrastructure to support reinforcement learning because Kafka clusters would just fall over at a certain level of scale. And so, the meeting stops like in the middle or pauses, and customer realizes that they never had to build that if they just had, kind of known that we existed and that we've solved for problems of parallelism that were previously thought to be unsolvable. And so that's the special part. And that just kind of entitles us to kind of go and keep inventing and incrementing on this new product concept. Now that we have, a compute runtime that runs in the system, that's a parallel computer. And so I think what we've built is really special and really unique. And for better or worse, there hasn't been anybody trying to kind of approximate that. I have a whole variety of reasons why I think that's the case, but
because it's hard to do, Jeff.
Well, yeah, it's
it would
hard.
Take them a very long time, and why go through? Why reinvent the wheel if Vast has already done it?
Well, that's the key. So actually, we're talking about it now, so we're just kind of shooting the breeze. So when we started in the storage space, there was an investor, a very public investor. I won't say who they are. Went around the world and said storage is dead. And this guy had made a bunch of bad bets, lost his shirt, and was pretty sour about it. So he basically spent the mid 2010s just telling everybody that it's a bad market and he shouldn't even go after it. And so we weren't thinking about only building a storage product, but that's where we started. And so we just got going in a very unsexy time in the market, and we started building, and storage and database products coming in and out of the market fairly regularly. New systems architectures only come on a generational basis. So I think people that aren't studying distributed systems maybe don't appreciate all that we've invented. That's okay. Like, if the product works for them, that's totally fine. But to the point you made, like, once you have a certain amount of momentum, then who's going to pay to kind of try to catch us when we've made so much progress? And so the key for us at a business level was, okay, don't trip. And what I mean here is, don't overhire so that you have to make a correction, because those have kind of negative effects with the team. And just build a very, very consistent, kind of cash conservative business that allows us to not have to make quick changes or reversals from an engineering perspective. So we run the ship pretty tight, but at the same time, we've kind of just been on this constant path since day one, and now we just have a lot of leadership in the space.
One point to build on something that you said, that you came about when storage was this kind of unsexy topic.
Super unsexy. And
I remember, I've covered systems for many, many years, and storage was like, oh man, another storage story.
Yeah.
No one's going to read it.
Now look at you.
It's a capacity story. And one of the things that even when my job is to continue telling stories, technical stories, it's really hard to get people to stop thinking about storage, because this world that we used to know of capacity and drives, and that's gone. I think Vast has reinvented what's possible with data infrastructure. And because it's like we've used up all of our creativity points on systems architecture, thinking about GPUs and AI models, we're forgetting about some of the core stuff that's actually changed quite a bit in the last 5 years.
I would agree. Not to downplay the amount of complexity that the machine vendors and the chip vendors are working with. Like, their job is
sure
extremely hard.
Yes.
Let's be clear.
None of this is easy anymore. There's no easy story in it. Yeah.
No, like just the just the chiller and liquid cooling
Oh yeah.
challenges are fantastically complicated. So I don't want to downplay that, but I think in our case, we call it an AI operating system. First of all, because we now we have an SDK that you can program upon, and we take the capabilities of the system all the way down to the device driver level. So if you've got all the storage layers and the database layers and the indexes and the eventing infrastructure and the runtime, like you have a computer that you can scale, to a whole data center scale.
Yeah.
You have a system you can scale across data centers, and that's why we call it the AI OS. And I think the interesting thing is, if you look at it from a philosophical perspective, there's just a lot of ambition in this company, right?
Yes.
And an idea that we shouldn't be constrained by how people have built and kind of categorized and segmented their products up until now. I always love to use the analogy of a RAID controller. If I'm talking to a customer that is in the storage space, when's the last time you bought a RAID controller? And they kind of scratch their head and like, 20 years maybe,
Right.
15 years. It's like, right, at some point somebody figured out, well, I can embed the capabilities that you need for whatever that delivers into a more sophisticated product. It was Intel, and they said, okay, we can just put accelerators into a microprocessor. And so that's what we're doing. We're basically just folding in
Wait, you're like
all of these
Are you
capabilities.
saying you're like Intel, Jeff?
I'm saying we are building a full stack offering, and yeah, like, in the future we may not even be talking about storage. We just talk about your operating system.
I don't think so. I think all of these parts are going to come together, and VAST
Yeah.
is a big part of that.
Trying to be.
Yeah. Well, thank you so much for your insights, and thanks everybody for watching.
Thanks.